Hey everybody, happy Homebrew Wednesday. Just a quick update. I'm not brewing this week, so go over my what I have. I still have only about a case and a half left of my APA. That's going down quite well. Probably 3/4 of a keg of that honey nut brown. I have in the secondaries right now almost 10 gallons of a Belgian wit, sort of a hybrid clone of an Allagash white, and of course the 5 gallons of the ESB, which is still in the primary, but it's tailoring off. I should have that in the secondary on Friday. I do want to talk about yeast because I did have a couple of questions about aeration and yeast. Since I'm in this microbiology class, I have found out quite a bit of information on fermentation and that whole process. Educational, I guess is the word. So I'll go over that with you. Hopefully it doesn't bore you. So let's get down to the nuts and bolts here. Saccharomyces, the yeast that we use for fermentation, they're called Facultative Anaerobes. And fancy scientific word for meaning the yeast can respire or function in the presence of oxygen or without oxygen, but prefer oxygen. Let me try to clear that up a little bit. Okay. Every cell respires. It takes glucose and spits out, CO2 and energy. Our cells in our body do the same thing. Well, yeast cells do the same thing as well. And that level of energy is called ATP. I won't get into all of that, how that works and what that does. But that ATP is a unit of measurement, and the most efficient cell on the planet will generate about 38 ATPs. Our yeast cells are in the area of 30 to 34. ATPs. Now, what does that mean to us? It kind of explains why we get that real active quote-unquote fermentation when it's really not fermentation. When you get that first 24, for however hours it takes for the yeast to burn up that oxygen in the carboy or in the wort, the yeast will prefer the presence of air. The yeast will use a different cycle of respiration. And that respiration is called the Kreb Cycle and the Electron transport chain. That sounds all fancy, and I'll cut out in a minute and explain that a little bit. But that is the important part of why yeast have this active role at the beginning of, we call it active fermentation, but it's really not fermenting any alcohol. And that is the wow factor. You may say, what? You don't know. That's not true. But however it is, and if you do the research on the most recent research in microbiology, you'll find that what I just said is actually true, and that surprised me as well. What we call active fermentation really isn't active fermentation. There is no ethanol being produced then.
For every glucose molecule that comes into a cell, it's split into pyruvate. Pyruvate is half a glucose, basically 3-carbon molecule that enters the mitochondria as shown here. When it does that, it immediately sheds a hydrogen atom and cleaves off a carbon, and that carbon becomes CO2. And the other portion of that 2-carbon atom is acetyl-CoA. Now that begins the Krebs cycle, which happens to our yeast in the presence of oxygen. Okay, so that 4-carbon molecule that's already in the mitochondria merges with the 2 carbons and becomes a 6-carbon molecule, sheds off the CoA. And at this point it's going to pick up, shed a hydrogen atom and shed CO2 once again and become a 5-carbon molecule. Now this next portion of the cycle is real busy. There's a lot happening here down below with the electron transport chain, but sheds off a hydrogen atom, another CO2, and ATP, and there's a bunch of ATP being generated in the electron transport chain, which isn't shown here. Now we're back to a 4-carbon molecule, but it's highly charged here with hydrogen, so we're going to peel off a couple hydrogens here and become a low-charged carbon molecule ready to enter the Krebs cycle once again to pick up that second pyruvate, which is the other half of that glucose molecule. I know I'm moving kind of fast, but this happens twice in the Krebs cycle in the presence of oxygen. So you're shedding off CO2 1, 2, 3 times, and that's times 2. So that's 6 CO2 molecules released per glucose molecule. As you can see, that happens twice. And with the electron transport chain, generates 34 ATP, which is a whole bunch of energy in the presence of oxygen.
Okay, I just explained that Kreb cycle to you. Now that's what happens when the yeast are busy. They produce the most amount of energy, so they're thriving, and they're saying, let's reproduce, let's increase the colony. When they do that, and you saw in that cycle how all the CO2 is peeled off in those cycles. Well, that happens twice every time one glucose molecule comes in. You're spitting out all that CO2. The only byproducts in there are energy and H2O, a little bit of water, and CO2 like crazy. So that's why you see that rapid fermentation in the carboy. But I say fermentation because that's what we call it, but it's really active respiration. Okay, there's no alcohol, well, very little at this point being produced. And anyway, well, at this point, I want to show you the fermentation cycle and explain that to you, and you'll see that. So I'll break away for a sec. Come back.
All right, this chart illustrates the our yeast possibilities here. On the right-hand side, we talked about the aerobic respirations there in the mitochondria, and that's in the light green. But in the light blue is our anaerobic or lack of oxygen function. You can see the glucose comes in, gets split into pyruvate, and releases ATP there. And then we enter the left side of the cycle because we're using yeast, and that's the alcohol fermentation and CO2.
So now you see in the fermentation cycle, there's only those 2 units of energy, that 2 ATP are being produced right at the beginning when that pyruvate is coming in. Now that, remember, I explained that pyruvate is basically one glucose molecule cut in half. So that pyruvate is half a glucose molecule.
It comes in as acetaldehyde.
And then it's broken into ethanol and CO2. That process only generates a little bit of energy. So the reason why we would aerate, really, in the beginning, is the idea is to build up a huge colony of yeast that are ready for the days when oxygen is gone, or the hours that oxygen is gone, really, in that, and begin that whole fermentation cycle, so that there's tons of yeast, billions and billions of yeast ready for that alcohol fermentation when the oxygen is gone. So that's what basically happens, and that's why we aerate. But the jury's really out on that. Do you really need to aerate on an ale? Because there's plenty of oxygen just splashing it into the carboy, swirling it around, rocking the baby, or whatever you do. That's enough in there to get the yeast started and to build up a large enough colony to be able to hit that fermentation cycle. So now we're looking into our carboy now, and I'm not sure what day we're in here because I really don't know scientifically, and it would vary from batch to batch, when all that oxygen is gone from the wort and gone from the carboy. I don't know. I'm sure there's scientists out there that will know, but it would vary from batch to batch and how much oxygen is in there. But once the oxygen is gone from the wort, then the yeast go into a different format of processing or respiring, because there's no more air to respire with. So they can't use this Krebs cycle and electron transport chain and generate all this CO2. So they slow down, and that's when we see that slowdown. And
early fermentation is actually rapid cell respiration and cell growth. Very little ethanol is produced until the oxygen has been depleted from the wort.
And that slowdown is when it shifts to ethanol production. Now we're producing ethanol. Now we're
truly fermenting.
And that was the big wow factor for me. That's the takeaway from this video. I hope you guys get. So future experiments, what I'm going to do when I split my batches is I'm going to mark the sediment at the bottom of the first, let's say, 8 hours. And then I'm going to go ahead and let it actively ferment. And when it hits probably day 5, I'm going to go ahead and measure the sediment in the bottom of each carboy and see which one is more. Because I think going to happen is, because I aerated one carboy and did not the other, the one with the aeration is going to have a thicker yeast cake in the carboy, and here's why. If you remember me explaining that Krebs cycle, where the yeast are able to utilize that to reproduce, and they're still burning up sugars, but they're
reproducing instead of fermenting.
So thinking is that on the experiment, that because they had more oxygen, they were able to utilize the Krebs cycle longer, produce more of themselves, and then after the fermentation has settled out, that yeast cake was thicker because there were more active yeast cells in the wort. Okay, so that's what I'll be checking on next. That's part of this experiment. I'll update on that. I know maybe a boring subject for some of you guys. You go, yeah, I don't really care. I put the yeast in, it works. But you know, some of you guys might want to know, well, do I need to aerate? Why would I aerate? What's the purpose? What is it accomplishing? Those type of things. So I hope this video helps that. If I confused anybody, I apologize. If I insulted anybody's intelligence, I apologize as well. If you have questions or comments, put them down below. I'll be willing to, address them, answer them as best as I can. There are some Wikipedia articles that are unsubstantiated that claim that there's fermentation going on in the aerobic conditions. That is not true. They can't back that up with any citations. So, however, there are plenty of others that back up my my video. So, cheers.
Okay, let's wrap this video up. Early stages of fermentation is really active respiration in the presence of oxygen. Ethanol is not produced until oxygen has been depleted from the wort. Aeration helps the yeast to grow a healthy population before they can actually begin the fermentation cycle. In conclusion, aerating high-gravity beers and lagers is recommended. I feel it's optional on ales. Thank you for watching. Happy Homebrew Wednesday.
Come and dance with me. Come and dance with me. Come and dance with me.